Okay, so hello everyone. My name is Kunal and I am your mathematics tutor. And today is our lecture number third of definite integration. So let me recap one thing कि अभी तक हमने क्या क्या पढ़ रखी है. So we actually deal with the like definite integration क्या होती है, what its geometrical interpretation. So वो क्या दिखाता है, तो it's basically the algebraic sum of area. The third thing we read is actually some basic property, and we also proved it. And then in yesterday lecture, we actually read about some reduction formula like sine to the power nx dx if we integrate from 0 to pi by 2, and if we integrate cos to the power nx from 0 to pi by 2. So how to do it with reduction formula, and we also proved Wallis formula too. Now in today's lecture, first we deal with some problems, some important problems which are of simple manipulation. So today's lecture mostly based on manipulative problem. So let me start today's lecture. Today is our lecture number third of definite integration. Okay. So what we have to do here, we have to actually, it's mostly based on manipulative problem and property. Like how to manipulate the given integrand in a given limits, like upper and lower limit are given. So how to manipulate it. So this is the things we have to learn before going to the tough problems and the property as well. So let's move on to the problem. This is the problem number one, which actually look like we have to integrate from 0 to 1. This is 0 our lower limit, 1 is our upper limit. And we have to integrate our function, which look like sine inverse of root x and divided by the root x 1 minus x dx. So this has to be integrate in between 0 to 1. So if we notice here one thing, there is something 1 minus x, right? There is something 1 minus x. So we know that wherever actually we already read in indefinite integration, trigonometric substitution part. If you are remember that thing, trigonometric substitution, that we read that if somewhere we found like x into 1 minus x, so what we substitute here, we actually substitute here either x is equal to a sine theta or a cos theta. And then we proceed. But here a is equal to 1, so we can, so here we have to substitute. We have to substitute here x is equal to sine theta, sine square theta. And or we can substitute x is equal to cos square theta, whatever we want. Now, let's find the elementary element by differentiating this. So when we differentiate, one thing I will tell you in our lecture number 1, कि this is the value of x. जिसके रिस्पेक्ट में अपने इंटीग्रेंड इंटीग्रेट करते हैं ना, उसकी वैल्यू यहाँ पर, this is the actually value of elementary element. Because we are integrating in respect of x. So the x varies from 0 to 1. Here x varies from 0 to 1. This has to be noted. Now, the dx is equal to, which is when we differentiate this function, we get 2 sine theta, cos theta, d theta. Right? Okay. Now let's move on to our given integrand. So our given integrand will something look like when we 0 to 1 sine inverse of root x divided by root under x into 1 minus x dx. So when we substitute the value of each thing here, what we get? First, our limit changes. So when we see here how our limit changes, so let me write here. Limit variation in terms of theta. Because our new elementary element is d theta. And what is our, so there is x is equal to sine square theta we substitute. So when the x is 0, sine square theta is 0. And when x is equal to 1, sine square theta is equal to 1. So we have to take the positive value. So there we get theta is equal to 0. And there from there we get theta is equal to pi by 2. So when x varies from 0 to 1, our theta varies from 0 to pi by 2. So this is our new limit in terms of theta. I hope you'll all understand this. So let me explain again how the limit variation. So the first, in given integrand, our limit variation in terms of x, but now we substitute x is equal to sine square theta. So our new limit varies in terms of theta. So the x varies from 0 to 1. Respectively, when we vary the limit in terms of theta, our theta varies from 0 to pi by 2. I hope you'll all understand this, what I'm trying to say. So let's move on to the now x substitution. So what we get here sine inverse of, when we put the root x, so we get, it will be like a root sine squared theta and divided by root under sine square of theta 1 minus sine square of 10. What is our dx look like? Dx look like 2 sine cos d theta, right? I tell you the shorthand notation of sine x is like this. Cos x is cos x. Okay. So let me solve this problem. What we get by applying the property of inverse trigonometric function, we get from here theta. There is like 2 sine theta, cos theta, d theta, and it's divided by, when the sine square theta comes out, it comes like sine theta, and it is cos theta. So this term get cancelled. So we get 2, 0 to pi by 2, theta d theta. When we integrate this, we get theta square by 2 into 2, 0 to pi by 2. And it get cancelled. And on substituting the limit, what we get? Theta square upper limit minus lower limit. So upper limit minus lower limit, it will be like pi square by 4. So this is our solution. And what we manipulate here, we actually use the indefinite integration trigonometric substitution part here, which we already read in indefinite integration part. And we just use the standard trigonometric substitution part here. Like if the function look like this part, we substitute x is equal to either a sine square theta or a cos square theta. And here the value of a is like 1. So we just substitute x is equal to sine square theta. And when we proceed on, we reach to this standard result. I hope you'll all understand this. Let's move on to the second problem. So our question, and one more thing, you can substitute cos square theta here as well. The result will be same. So no, so nothing to worry about that. We can substitute cos theta here as well. Now, our question number 2. It is the integrate. We have to integrate like 0 to pi by 4 sine square theta cos square theta divided by sine cube theta plus cos cube theta whole square theta. Right. So we have to integrate this, and here the theta varies from 0 to pi by 4. So what we have to do? Actually, we have to manipulate here. There is no other way to like solve this complex looking integrand other than manipulation. We have to manipulate, because if you do anything else here, it get complex. It get more and more complex here. So what you have to do? We have to just like we can divide here by cos square x, right? So what do? You have to just divide it by cos to the power 4x here. So what? So do here one thing. Divide numerator and denominator by what? Cos to the power 6x. Do that. So what we get? We are integrating from 0 to pi by 4, and when we divide like sine square theta cos square theta divided by cos to the power 6x, 6 theta actually, sorry. So this is our numerator part, and our denominator is like sine q theta plus cos q theta whole square divided by cos 6 theta. So look at here, when we simplify it, what we get actually, when we simplify it, what we get, our sinus, we can write it into like sine square theta by cos square theta into cos square theta by cos square theta and into 1 by cos square theta d theta. Right? We can write into this form. Now, when we take this cos to the power 6 inside the inside this function, what we get? We get sine q theta by cos q theta plus cos q theta whole square. I hope you'll all understand this. So let me write here the product form. So this make the function into tan square theta. This make the function 1, and this make the sec square theta. D theta, and divided by, when we divide it by cos q theta, what we get? What we do here, we just take cos to the power 6 theta inside the uh inside this bracket. So what we actually get here? So actually we get here is uh sine q by cos q. So it will be like 1 and tan q theta. Cos q by cos q 1 and sine q by cos q will be tan q theta whole square. Now what we have to do? We have to substitute here. Look, this is not a one-liner problem. What we do here is, this is mostly based on manipulation and some property and some substitution, which we already read in indefinite integration part. So you have to sincere here. Like, these are not one-liner problem. How I approach any problem, you have to focus on that. Not likely because this is because this is not same problem you're gonna face in your exam. But there is an idea like how to approach the problem. What I'm teaching you is the same thing. So these are not a one-liner problem. If you look at this, we are doing a lots of thing in problem 1. This is not a simple integrand at all. We are just integrating it from 0 to 1, but we are using the indefinite integration part, applying here whatever we read it here in trigonometric substitution thing. So we are applying here, and then we do some substitution, and then we proceed on, and then using the property which we read already in the first and the second lecture of definite part. So we are using that, and then we get to the final result. So this is not a one line problem. You have to follow a certain state, and you have to always aware that what I am doing next. So let's like in this problem, what I do? I do some manipulation here. I first I like we have to create like sine and cos. So sine and cos are related to tan. Like sine by cos theta is tan, and tan theta and sec theta, sec square theta are interrelated by differentiation. So you have to take an idea like if we divide this numerator and denominator by cos 6 theta, cos to the power 6 theta, so we can create here the tan theta and the sec theta term. And we know that the tan theta and the sec theta term are interrelated by their differentiation. Like the differentiation of tan theta is a sec square theta. So we are using those things there. And now you have to substitute here 1 plus tan cube theta as some x. Now again thing you have to notice that our in this integrand limit varies from 0 to pi by 4. Like, and now I substitute the x is equal to 1 plus tan theta. That means I'm going to integrate this function in term of x. So our variation of limit also occurs. So you have to look into it also. So let's move to the this part. So you have to differentiate this. So the differentiation of 3 tan cube theta will be like 3 tan square theta. And then differentiation of tan theta will be sec square theta is equal to d theta is equal to dx. Right. I hope you'll all understand this, what I'm trying to say. Now, what we have to look here is limit variation. How our limit vary. This has to be noted. Like lower limit, like directly right now here, theta varies from 0 to pi by 4. So here get clear like lower limit is 0 and upper limit is pi by 4. And now here we substitute like 1 plus tan q theta. So x lower will be like 1 plus theta lower. And the theta lower value is 0. So x lower value is 1. So this is the lower limit in terms of x. Now, the upper value is pi by 4. So x upper is equal to 1 plus tan q pi by 4. And tan pi by 4 value will be 1. So 1 plus 1, so it will be 2. So it will be equal to x upper limit. So when theta varies from 0 to pi by 4, according to our substitution, x varies from 1 to 2. So you have to note that. Now, what is our given integrand? Our given integrand is sine squared theta cos squared theta d theta divided by sine q theta plus cos q theta, right? And it varies from 0 to pi by 4. Now what I'm doing, now our x varies from 1 to 2, and our function look like there is the 1 plus tan cube theta square, we put x. So in denominator, we get the x squared term, right? And whatever written in numerator here will gonna count in dt, actually dx term, right? Because our dx is 3 tan square theta cos square theta, right? So if we put here d theta is equal to, we'll get dx by 3 tan square theta sec square theta. And the same thing written in numerator as well. So what we get here, dx by x square. And we know that the integration of dx by x square, it will be like minus 1 by x, right? 1 by 3 into minus 1 by x. And we have to put the limit, insert the limit from 1 to 2. So it will be like minus 1 by 3, 1 by x from 1 to 2. Now it's time to insert the limit. So we have to insert the first lower limit, and then we have to insert the, first we have to insert the upper limit, and then we have to insert lower limit. So what we get here, minus 1 by 2, and when we solve this, we get minus 1 by 2. So our final value is 1 by 6. Look, मैंने क्या क्या करी एक बार फिर से मैं आपको यहाँ पे दिखाता हूँ. Then everything gets clear to you. Look how big problem is. Like it's not a one-liner. I'm again saying you have to follow certain steps to solve this kind of problem. This kind of problem are manipulative. So what I'm doing is first I manipulate and divide it by cost. Somehow I try to, by practice, I try to manage, like if we divide this function by cos to the power 6 theta, we are getting tan and sec term. And they are interrelated by differentiation. We're doing the same thing. And we get to the result here. Now what I use the technique of substitution, which we already read in indefinite part. So we use that by substituting x, and then the most important thing is the limit variation. First we integrating in terms of theta, now I integrating in terms of x. So when theta varies from 0 to pi by 4, how our x varies? So this thing is to notice in a very careful manner. Otherwise, a single mistake leads to a very big difference in your answer. So you have to aware of that. I hope you'll all understand this. Now let's move on to the another problem, which also based on manipulation too. So this is the problem number 3, which is actually look like. Okay, now like here you one thing notice that if we write this integrand as I, so I is a function of x only, like it's only consists of x, right? If you notice here one thing, if this is our I, we are actually integrating in terms of theta. We know that. So this is our integrand. So this is a function of theta only, right? What if our integrand is, a function of two things? 0 to pi by 2, we have to integrate. There will be like dx by 1 plus cos theta cos x. Now, if you notice here, our integrand is function of theta and x as well. It is function of theta, it is function of x. So now there is a confusion. Our limit is x or theta, right? There is a confusion. Our lower limit is 0 and upper limit is pi by 2, but is this x or theta? Is it varies with respect to x or varies with respect to theta? This is the confusion here. But if you go through the basic of the definite integration, I'm telling you again, it's integrating. If we look through the elementary element, which is actually dx, that represent our integrand, integrate in terms of x. That means whatever written in our limit, this is not the limit which varies in terms of theta. It's actually the limit which varies in terms of x. Because our integration, our integrand integrates in terms of x. Whatever, if there is written is d theta, let us suppose there written is d theta. So the theta varies from 0 to pi by 2. Now, a part of that, we notice that in starting, we are claiming that our integrand is the function of theta and x as well. It is, but it is only integrating in terms of x. So our integrand, so let me erase here. I just write it for try like make you understand like हो क्या रहा है यहाँ पे. So our integrand is only the function of x, not the function of theta. Because our integrand integrate only in terms of x. Now, how to proceed for this problem, right? So we know that we actually read in, again, we are connecting it to indefinite part. We are uh, already reading. Let me raise it and write it clearly. Actually, we are already of we are of we are already reading. We are already cover the trigonometry standard cases, right? Basically, here the cos theta is treated as a constant part. We can write this integration as 0 to pi by 2 dx 1 by a cos x. You can write. And we read in indefinite integration trigonometric standard cases, like if somewhere you found the integration of a cos x plus b sin x plus c sin x cos x, right? Plus c sin x cos x or whatever you find. So what you have to do, you have to differentiate it by tan square x, right? I hope you'll all understand what I'm trying to say is. So just you have to do divided by cos square x. Do nothing, just divided by cos square x. But first you have to do here some manipulation and then you have to proceed on. Or either you can do one thing more, like this is for noted. Let me write here clearly. This is of the type like dx by a sin x plus b cos x plus c. But here in our given integrand, dx by 1 plus cos theta cos x. So if we compare this to our indefinite integration standard form of standard cases of trigonometric function, so what we get that here sin x term is missing. That means a is equal to 0 and b is equal to cos theta. Right. So what we have to do in this kind of problem, we just write sin x as 2 tan x by 2, 1 plus tan square x by 2, and cos x as 1 minus tan square x by 2 by 1 plus tan square x by 2. So we are connecting to indefinite integration part, right? We are using the concept which we read in that part in now. I hope you'll all understand this, what I'm trying to say. So now, when we move to the our integrand, it like 0 to pi by 2. Now substitute. Now here the sin x term is missing. So we don't need to substitute this, but there is cos x term. We had to substitute this in place of cos x. So it will be like dx 1 plus cos theta. And what we have to write as cos x? We have to write this term as cos x in place of cos x. So like 1 minus tan square x by 2 divided by 1 plus tan square x by 2. I hope you'll all understand what I am trying to connect. I just try to make a bond between indefinite and definite. There is not a much difference between indefinite and definite. Both are integration. Indefinite part, just limit comes. We have to just insert the limit. I hope you'll all understand this, what I'm trying to say. I am using the concept which we already read in indefinite part. Like if this kind of our integral look like? So we have to substitute sin x and cos x as this. And the same thing we are doing here, but in last, what we do, we just substitute the limit, just insert the limit. Now proceed on here. First simplify it. So it's like 0 to pi by 2. When we simplify it, this go in numerator. So 1 plus tan square x by 2 dx. It will be like 1 plus tan square x by 2 plus cos theta minus cos theta tan square x by 2. I hope you'll all understand this, what I'm trying to say and do here, right? Now, what we have to do here, in numerator, 0 to pi by 2, it will be like 6 square x by 2 dx. And like in numerator, if we notice one thing, what we get actually, if you, let me read it first. Okay, so let me write here 1 plus tan square x by 2 plus cos theta minus cos theta tan square x by 2. If we substitute tan x by 2 equal to t, so what we get here actually? Like our final goal is to create the tan and x term because both are connected by differentiation, and we do here. Like we get some tan x term, this is cos theta is constant, and we get the sec square x term. So what we have to do now, I have to just use the a simple substitution of t is equal to tan x by 2. So first look at the limit variation, how our limit vary. Because limit variation is most important here. How our limit vary. So this is actually important because limit variation is the thing that you have to notice in a very careful manner. Otherwise, you miss the concept as well and you don't reach the answer. Big variation you face. So the limit variation is like our x varies from 0 to pi by 2. That means our x lower is 0 and x upper limit is pi by 2. Now, the tan x by 2 is equal to 2 we substitute. So the t lower. Now what am I doing? I'm just substituting in terms of t. And the t upper is equal to, actually the x value is pi by 2. So it will be like pi by 4. So we get the value 1. Now our integrand look like 2 into 0 to 1 dt, and it's divided by 1 plus, actually cos theta is the constant term, cos theta plus 1 minus cos theta, and there is the term like t square. I hope you'll all understand what I am doing here. And now this is actually if we write here, so this is our A and this is our B, right? I hope you'll all understand what I am trying to do. So this is of the form like dt by A plus bt square, right? So we can write this into like A square plus B square term, right? So we write here first like I is equal to 2 by 1 minus cos theta, and we are gonna integrate that dt by 1 plus cos theta by 1 minus cos theta. We just take cos 1 minus cos theta common because we have to make the coefficient of x square is equal to 1. We already read this concept. We are just applying here and inserting the limit. And you have to practice it a lot. We are just doing the same thing that we do in indefinite part, but their approach is different. Their application is different. And one more thing we have to do here is limit how our limit vary. And the second thing, how to insert the limit, which is simple. The limit variation is also simple. If you practice a lot, you get and you feel like it's easy. Because if you look, problem is not one liner. It's look at here. This is our problem and it's this is not one liner. Okay. So try to solve very in a careful manner. Now uh there will be like t square. And we know that 1 plus cos theta is equal to, we know in trigonometry, you all read that like 1 plus cos theta, we can write it into 2 cos squared theta by 2, right? This is the formula. And 1 minus cos theta is equal to 2 sine square theta by 2, right? I hope you read this. So we are going to apply the same thing here. So 1 minus cos theta, we can write it into 2 sine square theta by 2. We are integrating from 0 to 1. Dt by 1 plus cos theta is 2 cos square theta by 2 and denominator 2 sine square theta by 2 plus t square. And then it will be like 2 by 2 sine square theta by 2. It get cancelled. No doubt 0 to 1. Dt, here we get cot square theta by 2 term, right? Plus t square. Now when we integrate this form, this form is like a square plus t square term, right? So integration of this is 1 by a tan inverse of t by a. I hope you'll all understand this, what I'm trying to say. So just write here. So it will be like 1 by sine squared theta by 2. And then it will be like 1 by a cot squared theta by 2. And then tan inverse of t by cot theta by 2. 1 by a na. So there will be like only theta term. Now tan inverse of cot theta by 2. I hope you'll all understand what I write here. And then you have to substitute the limit from 0 to 1. Now it's time to substitute the limit. So do it in a very careful manner. Right? So first try to, because we are inserting the limit in t, not in theta. So don't try to do mistake here. So sine squared theta by 2. Cos theta will be like cos theta by 2, sine theta by 2. And then when we substitute limit here, what we get actually. So it will be like tan inverse of 1 by cot theta by 2. So, and the 0, and when we insert the 0, it becomes 0 because tan inverse 0 is 0. So this get cancelled. In numerator, what we get? We get sine theta by 2 cos theta by 2. Right? Sine theta by 2 cos theta by 2. And when we solve, what we get? Cot theta by 2 will be, when we take inverse, so we get tan theta by 2. And after solving it, what we get? We get actually tan theta by 2 sine theta by 2 cos theta. We are using inverse trigonometric function concept here, and we play cos theta by 2. And we know that this whole value is equal to sine theta. So our final answer is theta by sine theta. I hope you'll all understand this, what I'm trying to say, right? So this thing we have to do here to solve this problem. Like cos theta, cos x. Their lookup function is of two variable. Like first there is confusion like either theta is vary or x is vary. But when you notice this thing, you will get to a result that like our integrand is integrating in terms of x. So there is no variation of theta. Theta is taken as constant. Our integrand is integrating in terms of x only, right? So this thing that you have to notice. And what we do here, we do first manipulation. We use some standard trigonometric function cases, and then we integrate, and then we use the limit variation concept. We variation the limit in terms of t, and then we use some trigonometric function as well. Inverse trigonometric function that you already read in ITF chapter, and then we get to the final answer. Let's solve a tricky question. Okay, so this has to be noted. This is actually very important question. So let me write the question here. So our question is, so our question look like we have to integrate 0 to 1, r is equal to 1 to 40, x plus r, summation of k is equal to 1 from 40, 1 by x plus k dx. If a normal person look at this problem and you told him to solve this, then what's it out? ये क्या लिखा हुआ है इसमें? If you understand the symbol, like what is it? If not, then let me explain first. This is the symbol of summation. Basically, its work is like whatever written here, like summation k is equal to 1 to 40, 1 by x plus k, we can write it into this form, like first k is equal to 1, so write it k is equal to 1, then 1 by x plus 2, because the next time we come here, the k value is 2. So next value is like 1 plus x by 3 dot 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 dot. Is like 1 by x plus 4 dot dot. कहाँ तक जाएगी? 1 by x plus 40 तक. Okay. So this symbol represent summation. You have to know this. अगर नहीं पता था तो बहुत बढ़िया, नहीं पता था तो this symbol is known as summation. जिसका काम ये होता है कि whatever written we just substitute here the value of k in each time. 1 by x plus 1, 1 by x plus 2, 1 by x plus 3, 1 by x plus 4. Likewise, 1 by x plus 40. Now, what this symbol represent? This symbol actually represent the product, like the same thing that we do here. So if somewhere you find pi r is equal to 1 to 40 x plus r, that means it written in form of product. Like this summation represent each term written in terms of addition, and here each term written in terms of product. So like r is equal to, first put 1, so x plus 1. Next time r is equal to 2 into x plus 2, x plus 3, x plus 4, dot 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 dot, x plus 40. So if we actually open our integral here, integrand here, so what we get? So let me write here. Our integrand is something look like 0 to 1 pi r is equal to 1 to 40 x plus r, and then summation of k is equal to 1 to 40, 1 by x plus k, and then we have to integrate in terms of x. Like first thing that notice, the x is vary from 0 to 1. Now, if we open this, what we get? Like x plus 1 into x plus 2 dot 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 x plus 40 term, right? And then I have to add here like 1 by x plus 1, 1 by x plus 2, dot, 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 1 by x plus 40, and this. Like if we open this and this, we get this and this. I hope you'll all understand this, what I'm trying to say, right? So what I'm saying is you have to do one thing, like what if I substitute this whole term as t? That means here you gonna new things here because it is important. So if we substitute x is equal to r is equal to 1 to 40 x plus r, t is equal to, sorry, t is equal to, right? And when we देखो अब this is written, we can't differentiate in a easy way. अभी तक हम क्या करते आ रहे थे कि जो भी सब्स्टिट्यूट करते थे and then we differentiate and then we easily got dt and dx term, and we just vary the limit and we use the concept of limit variation and easily integrate करते रहते, right? But here you can't differentiate this pi r is equal to 1 to 40, like x is equal to x plus 1, x plus 2 in one times at a time. So what you have to do, just take log both sides. Let me read it first. So what you have to do, just take the log both sides. So ln t is equal to, and you know a property of log. Let me recall here if don't. This is the property of log, like ln a, b, c, d, e, f. Of the same base, we can write it as ln a plus ln b plus ln c, right? Dot, 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 ln e, right? So we are using the same property here. ln pi r is equal to 140 x plus r. Now, if you open this, you get the result ln. Try to open this. So what we get? X plus 1, x plus 2, dot, 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 x plus 40. This same term like look like this. So we are using the simple logarithmic property. What we get? ln x plus 1, ln x plus 2, dot, 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 ln x plus 40. Now what you do? Just differentiate it. Now differentiate it. So now when we differentiate this, we can differentiate the log. What is the differentiation of log? Differentiation of 1 by t. 1 by t dt is equal to 1 by x plus 1 dx, 1 by x plus 2 dx, dot, 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 1 by x plus 40 dx. Now, in starting, we go through it. Like, we get this result. So what I'm saying is कि 1 by t dt, if we take dx common, what we get? 1 by x plus 1, 1 by x plus 2, or 1 by x plus 40. And this whole term, we can write it into k is equal to 1 to 40, 1 by x plus k. This whole term, right? So we can write 1 by t dt is equal to summation of k is equal to 1 to 40, 1 by x plus k dx. Okay, we write this term as into this term. Now again write our integrand look like 0 to 1, pi is equal to r is equal to 1 to 40, x plus r, and then summation of k is equal to 1 to 40, 1 by x plus k, and then dx here. What I do, I just substitute this term as t, and what we get, this whole term as 1 by t dt. Look at this, how simple it is. But one more thing you have to notice. You have to use limit variation here. Okay, you have to use limit variation here. So first try to get the limit variation. How limit vary? So we are substituting t is equal to pi, r is equal to 1 to 40 x plus r. Or we can write t is equal to x plus 1 dot x plus 40. Or all are written in product. Right. So if our x is 0, our like x lower is 0. Here is 0 and x lower is 0. And x upper limit is 1. So if we substitute x 0, so the t lower is, in all we put 0. So what we get? 1 into 2 into 3 into dot 40. So this is written as like 40 factorial. What is n factorial? Like n into n minus 1 dot 1. So it will be like written in 40 factorial. When we get the t upper, substitute the value 1 here. So it will be like 2 into 3 into dot 41. So it will be written as 41 factorial. So now when we go through the integrand, so it varies from 40 factorial to 41 factorial. And our, this is t, then this is our 1 by t dt. Actually, we get here, right? This whole term is written as 1 by t dt. So t into 1 by t dt. And when we solve this, we have to just integrate the dt. So we get the t and just substitute uh, the upper and lower limits. So what we get? 41 factorial minus 40 factorial. And when we solve this, what we get? 40. Take 40 factorial common. So it will be like, when we take the 40 factorial common, we get 41 minus 40. 41 minus 1. Sorry, let me read it here. 41 minus 1. So we get the final result as 40 into 40 factorial. This is my final answer. So what things you have to notice here? I am again saying, this is first. अगर कोई भी इस प्रॉब्लम को देखेगा तो पहले से तो दो चीजें होंगी, या तो इसे समझ नहीं आएगा कि सिंबल का मतलब क्या है, बट मोस्ट प्रोबेबली आ जाएगी क्योंकि 10th 11th में ये सारी चीजें यूज हो रही होती हैं. तो इफ यू गेट थ्रू द सिंबल, तो मैंने सिंबल बता दिया, एंड देन फर्स्ट यू हैव टू राइट इन expanded form to analyze the what problem want. Whenever you don't understand the problem, try to use and go through the basic. So first we know that this whole term is written in like this and this whole term written like this, and then we take the log because we cannot directly differentiate this whole function. So then we take the log, and then what I do, I just substitute, and the t is equal to pi r is r from 1 to 40 x plus r. Then I get, if I substitute that, we get the summation term in terms of dt. And then when I do that, we get to a result like it converted into a simple integrand. I hope you'll all understand this, what I am trying to say. So this is actually easy, right? You are nothing to afraid of. So today's lecture is mostly based on manipulative problem, like how to approach the problem and how to use the concept of indefinite integration, indefinite part. This is the most important thing that you have to learn. How to use the concept that we already read, because ये कुछ नया chapter नहीं है. This is the chapter that only have some more property and limit insertion हो रही है. That's the major difference. वो उसकी geometrical representation थी that it represent the parallel graphs, parallel curves, and it represent the area. That's it. So that's all for today. In tomorrow class, we are gonna read some more property, approachable problem. Just try to develop like how to solve the problem, because this same problem are not going to ask in your exam. Sometimes it will, but the chances are very low. But the things that you have to learn, how I approach the problem. मैं कैसे प्रॉब्लम को अप्रोच कर रहा हूँ, लाइक अगर मैं पहली बार ये प्रॉब्लम को सॉल्व करता, आई डोंट नो लाइक हाउ टू सॉल्व, बिकॉज इसमें कुछ सामने से देख के समझ नहीं आ रहा. अगर मैं एक दो बार कर चुका होता, देन आई नो द प्रोसीजर कि अच्छा ऐसे ऐसे करते हैं, ऐसे ऐसे करते हैं, ऐसे ऐसे करते हैं. बट पहली बारी अगर मैं करता, अगर पहली बार इस प्रॉब्लम को देखता, देन हाउ आई अप्रोच, आई जस्ट गो थ्रू दैट. कि अगर मुझे समझ नहीं आया, देन आई ओपन द पाई वन टर्म एंड ओपन द समेशन वन टर्म, देन ट्राई टू एनालाइज कि अच्छा इसके बाद वी कैन टेक लॉग एंड देन डिफरेंशिएट सो वी गेट द फाइनल रिजल्ट, राइट. बट अगर मैंने इस प्रॉब्लम को लाइक अगर ऑब्वियसली पहले से करा रखा था, अगर अप्रोच नहीं होता तो लाइक वी कैन डायरेक्टली गो थ्रू द, एक दो बार कर चुके हैं सॉल्व, देन डायरेक्टली मूव टू द ओके, वी नो दैट the if we substitute this term as t, so we get the summation term as dt. So I do I do directly there. And limit variation तो एक लाइन की है, we can do limit variation easily. So this is the thing that you have to learn. Approach is more important, like how to approach any problem of integration. Okay. So, okay, that's all for today. Tomorrow we discuss some more property and problem. Thank you.